Okay, with this problem, we're gonna have to use quite a bit of these theorems or laws. So we're gonna go ahead and start by copying down the problem. And breaking that down. So it's over here. So I think the very first thing we're gonna do is use the quotient law for limits, because that's going to allow us to break it into numerator and denominator. So let's do that first. So I put the equal sign over here, but I'm going to write it over here. So I've got the limit as x approaches -3, and we've got numerator. And then denominator. That's a 2. All right, now we're going to go ahead and apply the difference law. Well, it's actually both of these. Because what that's going to allow me to do is to break up anything that has a sum into 2 separate limits, and anything that has a minus into 2 separate limits with a minus sign. In other words, let's take the numerator and let's write it as a limit of -3x cubed minus the limit of 5x plus the limit of 7. Okay, and all of those are going to be as x approaches -3. For saving time and space, I'm going to leave that out. And then I've got this one. I'm going to use a quotient. I'm sorry, the difference for limits law. So it's the limit of 2 minus the limit of x squared. All right, now let me bring out these coefficients. I'm going to need to bring those out. So now I'm going to use the constant multiple law of limits. And that's only in those two. So it's going to be -3 times the limit of x cubed minus 5 times the limit of x, of x plus the limit of 7 as x approaches -3. Limit of 2 minus limit of x squared. Okay, now I want to use the power law, which means that it allows me to take a function raised to some n and to bring the n outside of the limit. So -3 parentheses limit of x to the 3rd power, and then I copy the rest. Now I think you see why I left the x to as x approaches -3 out. Limit of 3, that's the numerator, and then the denominator is that, and we're going to let me just verify that I did that the right way. Yeah, so then again I'm going to use the power law. So this is the limit of x squared. Okay, so I think I've sufficiently used all of those limit laws. And so for space, I'm gonna remove this window here. And I'm gonna use the basic limit result theorem, which lets me almost gonna wrap this up. So let me work on this. So this is -3. And then as x approaches, I gotta bring that back. -3. So this is -3 to the third power. So I'm using this rule. Minus 5. I'm going to bring back the as x approaches -3 piece. So this is also going to be a -3, except this one doesn't have the cube part. And then I'm going to use this rule with this. So that's just a 3. And we're almost there. This will utilize this rule. So this is going to be a 2. And then I'm going to utilize this rule. So this is going to give me -3, but I have to not forget the 2 there. All right, now this is going to be 81. This is 15. This is 3. And this is 2 minus 9. And let me just double check that. That's 27 times 3. It looks fine to me so far. And then let me add up all that. So that's 1899 over 7 is what I'm getting. So I'm going to stop the recording just for a second so I could check my work. Okay, and so I did find one mistake, and somehow this limit 7 with my poor handwriting became a 3, but it's a 7. So this is a 7. That's a 7. And so that is $103. 103, and this is a -7. So we could put the minus in the front. And that's how you do this kind of problem.